And we are live. Hey everybody, hope you are doing well. Sorry I'm not going to show my face tonight because I look like a hybrid from Frankenstein and The Simpsons. so so tonight it's going to just be I think a nice chilled debate on Discord night. I think it's going to be quite a good thing to do maybe once in a while. Who do we have in? We have Bacon. Hi sir. We have Brian Lee, good to see you. Demon Stride, thank you for coming. Glot Flab and Lowry Letenu and obviously PJ Cruikshank. How are you guys doing?
Yeah, good man. It's good just to pop in Discord and see about, 7 people, yeah. Cool.
Yeah, might be a couple more too, but yeah, let's keep it above the belt, guys. This should be fun.
Absolutely, glad to be here.
Awesome. Yeah, it'll be interesting to see what people, what the argument's going to be and what evidence people bring. So I think it'll be great. And then I just want to say hi to everybody in the chats. Good to see you. Thank you for coming. I'm so glad you guys are all here. I do have a poll running. Globe just cannot provide evidence. We got no because it's just fantasy 62%, and yes because here it is 38%. So obviously 38% of the people should be bringing their Globe evidence. So yeah, when you guys are ready, I don't know who wants to pick it off, who wants to start with an argument, and we can have rebuttals and so on. So there we go.
I do have a quick question. Can you put the link to your YouTube in the chat, please?
To the YouTube and the Discord. Okay, let me quickly...
Yep, that'd be great.
I think we're outnumbered, guys. Come on, man. We need a couple of...
Is PJ a Glober? Is PJ a Glober? You Glober, PJ?
Nope.
Yeah. I'm not a Globe, no, sorry. I just said jet then. no, I'm over.
Okay, let me quickly stick it in the chat there for you. I'm gonna show chat.
We're pretty much tied. I mean, we're 3-4, right?
Yeah, it doesn't matter. I mean, us flatties are anyway used to facing like 20 against 1, so it's fine.
There you go. Before we get into it too deep, I wanted to give a shout out to my brother across the pond, Brian's Logic. We don't always see eye to eye, but I like the way he thinks. He brings some great arguments, and he's on topic and on point because we got nominated for Top Left Award. So I'm honored first. That means we're right over the target, and Flatzoid's on that list, and others. So I just want to put that out there.
Yeah, we feel honored because then we know we're doing something right.
Absolutely right. See, it's all about the audience, because the truth will defend itself. Exactly.
So guys, the Discord chat is linked, is put in there for you guys. If you guys want to come to Discord and debate. We see Peaceful Warrior has also joined. How are you doing, Peaceful?
Hello, doing well, thank you.
Okay, so
sorry lads, all is well. Cheers.
That's good. So what's the first topic you guys want to discuss about?
I want to say this, I think you did a great thing by having David on, because in other Discord chats, like over at Earth Awakenings, and it's been like the hot topic with the spherical excess argument, and it's a lot of information. I mean, it's a lot of information, loads, but I've glanced over it, and that's been the hot topic. So he pointed out that not all of the angles, even in their surveys, the actual measurements, now we're talking actual measurements, are they have their arguments, but the point is they don't all add up to over 180 degrees, and even in their geodetic survey, and that's kind of been the top. So they have some good points, and I think just that fact alone is is pretty strong argument that they don't have things perfect as far as their map. They have a model, and nothing more. That's my opinion.
Yeah, no. Richard, try not to be a dick, says, let's discuss Globers having no evidence. Yeah, because that's the thing. When they do try and provide evidence, they're actually just proving it to first be measured flat or horizontal planes. I mean, it's exactly what they did with the spherical axis. They were showing horizontal surface distances for over 4,000 kilometers, and then just claiming curve.
And here's my point. So in the columns, they have the actual measurements from all the stations, and then they have the very next row is corrections. Now, in your debate against David Johnston, I think that's his name, he said that it's his favorite proof because it's only side-to-side azimuth measurements and no up and down, no refraction. And so so every single measurement has a correction.
Mm-hmm.
So if they're not correcting for refraction, I'm still waiting if there's any glober here or anybody listening, what is the correction for? Why are they having to correct every single measurement? Me personally, I think they're correcting it to fit their model and their globe distances and whatnot.
Yep.
If anybody has an answer.
Yeah, there was an explanation for those corrections. It's I mean, that's why I said in the beginning, I don't know much about this. It would be best if we had someone that do know about it. But I've seen them explaining it, even though I didn't understand everything. To me, it looks like it's just an instrument error that you can correct based on other measurements you're taking. So you take a many measurements, and you can correct for one of those based on how much you're getting the other ones wrong. So it's not related to the globe or anything like that. As far as understood, it's just an instrumental error that you're correcting for.
Yeah, because the theodolites always have a margin of error that they have to account for. And because they're having line of sight and with the distances acquired, they have to take those errors into account because it's an optical instrument.
Right, but let's look at the topic. It's called the transcontinental arc of the parallel. So I think they tried to stick on or close to like the 39th latitude. But just saying it's arc right there, to me the corrections are to achieve the arc. But let's just say this: the measurements that are above 180 are very slight. The measurements below 180 are very slight. It seems like the longer they shot, the more excess. But in my field, I'll try and make this quick. And I do level for a living, do concrete. I've done some big projects, but I've used the auto levels constantly. Been using them for almost 30 years. And I'm not sure with the theodolite and the long distances, but I know in my field that the shorter, the more accurate. So the shorter shots we take, the more accurate. So if it's a critical job, we're gonna pull it in, 50 feet at a time and do short, precise measurements. The farther out, the more the margin of error. But I'm not sure, like I said, with the long distance theodolites. But
yeah, but that's what I said with the theodolites as well, because it's an optical instrument. The further you go out, the more inaccurate it becomes, and that's why they have to have those played into their calculations for correction errors. Not because of curve, but simply because there are inaccuracies the further you go out.
Well, it's not just related to the margin of error, because with the margin of error, you don't know in which direction you're getting it wrong. If you have some correction, it means you have something that tells you, well, I'm wrong in this direction or in that direction. That's when some techniques have to be used to get a good statistical correction for the measurements you're taking and to improve their accuracy.
Well, here's the best I got. The best I got is that they're looking, they're looking at the long distance shots and they're calling them more accurate, and then they're saying they're all off a little bit, right? And so they take and they join them to a common point. So if they're taking, let's say 5 lines or 5 points from surrounding triangles, and they're joining them at a common point, and then they're labeling them the correction. That's the best response I've got. But that, once again, is forcing the curve. And in my opinion, that's they call it the least squares method. And to me, that's an average basically. When I hear least squared method for jobs, I know that that's basically get it right out in the field, get it right on the paper with averages. Unless somebody wants to sum it up for me better than that. That's what I hear when I hear least squared method.
I think if you're claiming that excess is due to error, or that is how much we need to for the excesses to add up to 180. Oh, lower. Get Jesse Gordon here. That's great.
Okay, well-
I hope he understands the correction because I can't explain it.
Yeah, he probably does. But let me say one more thing. Maybe the angles, maybe them lines aren't supposed to line up. You know, maybe they are what they are. And like when we try and triangulate for like, say Polaris, you know, perspective and other things, they don't all line up. So maybe that's how they are supposed to be in the real world. Maybe all the lines where they cross aren't supposed to be exact. But I don't know, just thought.
Hey,
Well,
if you guys want to know, we do got Jesse Gordon in. I know he does a lot of the auto level and theodolite work, so he knows a bit more of the subject.
Yeah, he also doesn't have a working mic, I think, at the moment.
Oh man.
Sorry.
Hey Shane,
Oh,
good to
that's-
see you, mate.
Hey, what's going on, Shane?
Hey guys.
It's good to see you, mate.
Hey, Shane, so just to, I mean, the point I wanted to make is that we can take those corrections that are being applied and call that the error bar, so everyone's happy. And that's how much the measurements can oscillate, and we're going to attribute that to error. And then we can get those triangles and see if, considering that as an error bar, if that's still within the predictions of the globe, because it's quite easy to get predictions of the globe of spherical axis. So we can see if, given that error bar, if the bigger triangles, which are the ones that give the more, would probably predict excess bigger than those error bars, if that is matching the data.
So
I
then,
think
That's-
before we do
so
that,
that-
we don't have a very strong argument.
so that's then that's then just taking consideration of the belief of your globe then.
To me, that's what it sounds like. But hold on, at the very least, Bacon, guys like, let's say, McToon and Fight the Flat Earth, they've been using this argument for a couple of years, and we can debate it. But the fact is we heard them over and over. Like in McToon's debate against Ryan, he literally reamed this guy for not paying attention to detail and claimed over and over. He didn't say nothing about corrections. He specifically said that he said on a globe, every triangle has to add up to more than 180. And he reamed the guy for not knowing this and all that. And he claimed that over and over that they all added up, every measurement, more than 180. And the fact of the matter is there's more to it than that. So at the very least, he owes some kind of response to Ryan, man. It was pretty rude. And
Thanks, guys. I just want to say I got a super chat quickly. Thank you, Godzilla37, for $14 super chat. Really, really appreciate it, mate. He says, we're almost there, guys. Just one more decade until the global will provide the first globe proof. Okay, maybe not. But here's to hoping. Thank you very much for the super chat, Godzilla. Yeah, because when they do provide it, they either provide flat earth proof or they don't provide anything. So that's about it. Thank you for the super chat. Okay, go on. Sorry, guys.
I was almost done. So anyway, so McToon, you know, goes on modern day debate. I think he's like one of the first ones to bring this up and makes that claim, and then Fight the Flat Earth starts parroting him, and everybody starts parroting them, and then we get in this situation to where they're like in a degrading fashion, throwing it down our throat, saying every measurement is more than 180, when in reality it comes down to that there is several measurements that are less than 180, the actual measurement. So then we go to corrections, and then that puts the argument in the weeds. So now we got to argue about the corrections. Just the same thing with refraction, with like Black Swan and all that. So at least now we have we have it in the right position, and they need to stop claiming that all the triangles measure, like the physical measurements, are more than 180. That is incorrect. They're both higher and lower than 180.
Yep.
Also, I was going to say yesterday, me and Witsit were looking over that document, the translateral, whatever, the survey, and we had McToon on, and I pointed that out to him. Like, I saw your video, but I think what happened was you dropped your video over there, and he prepared for it. He knew it was coming. He added a sheet to his new spreadsheet to show me how wrong I was with my new argument, and then Witsit beat him up for a good long while on all the things that I think you argued. So I don't know if you caught that, man, but you should check it out. I think it's a new stance to argue from.
But that's what I said.
Absolutely will.
As I said, just before the live stream started, McToon contacted me. He asked if we can use some of those parts, circlips from the Andrew coming on. I said, yeah, sure, go. I'm not a guy that copyright strikes people, so it'll be interesting to see how he's going to save face, because those triangles did show less than 180. So
he did. So I'll tell you exactly what he did, and it made me just get disinterested with the whole thing immediately, right? So on the left you have the direct measurements, on the right you have the what I call sphericity corrections, right? They do corrections. The one on the right all equal 180, and his statement he then corrected to say, well, no, none of the corrected measurements are lower than 180. I'm like, you mean the ones that you made equal all 180? That's a ridiculous position. Fine, whatever.
Right. I mean, dude, we know how to add three angles. I was just making a point in my video. The ones I showed were a little more than 180, but I also pointed out the ones that were less than 180, and that's the whole point. So now we got to debate about the correction.
Well, so the whole the big thing was that the margin of error with the formulaic thing on I think page 62 of that survey indicates that the margin of error is like a little bit less than an arc second, so it's like 0.67 or something to like.
Which is hardly anything.
So, right, so they're using a margin of error about an arc second, a little bit less, and then claiming spherical excess about less than an arc second. And I went, you don't see an issue with that? And he goes, well, yeah, no, absolutely, that's a good point. But and then he has a whole other series with the different margins of error. Like he was prepared, man.
Well, the excesses aren't of like just one arc second. I think there were even on the
ones I pointed to were right, and then he pointed.
Yeah, and the averages too.
Right.
The averages. There were a couple that were in the seconds, but not many. That I see.
Andrew says,
Right.
what about the Salt?
Bigger, that's.
Andrew's saying, what about the
that's why I
Salt
was saying
Lake?
we should.
Oh, sorry, Bacon. I was just
That's
saying.
fine. Go ahead.
I'm just saying. Andrew says, what about the Salt Lake bassinet? All triangles greater than 180 degrees without corrections.
Yeah, well, that's what I was saying, that we should correlate the amount of the axis with the size of the triangle. If you're getting the bigger axis, the bigger triangles, and that's within the error margins, then that's not a win against a little bit.
Right, but here's how I see it though, Bacon. Okay, if the Earth was flat, let's just put your flat Earth hat on for 1 second, and I go out and I do all these measurements. Now, the closer I get, the more I get at 180 and just a little under 180. Okay, then the further I get, so naturally I'm going to think that the distance when we do these super long distances that they're not as accurate. And but either way, if you're getting error at all, then if the Earth's flat, you're going to expect measurements under, a little under, and a little over, and that's exactly what we get.
Yeah, but if those errors would be increasing with distance, which I don't think they would, because they're angle measurements and they're azimuthal angle measurement. But if they would be increasing with distance, you should expect just as much angles above as angles below 180 in further distances. They should oscillate more the further they are, not just get bigger. If they're just getting bigger, you get some consistency. That's not error.
That's an interesting theory. If I don't know if anybody's proven that. I strongly disagree from experience, but not with the long distance theodolite shots, but with similar instruments looking through scope. The margin of error is way less up close.
Well, if you're going away from the theodolite that is pointing at you in that same direction, your angle is not going to change left to right if you're going that same direction. It might change up and down because that's what refraction does. But there's no reason why you'd expect the angle to be deviating left to right if you're going away in that same direction. So if you're going in the same angle, the measurement of that same angle shouldn't change, even if you're very far.
So up close, up close we got concave shots, but that's just that's error from being so close to the target. So what you got to do is you got to get further away, and then it starts getting accurate, and then we start getting a sphere.
No, I don't get the point.
I was just being sarcastic, bro. I was kind of joking, but not completely. That's basically what you're saying is up close, where we're closer to the target, getting more precise readings. Then that's where our error is, instead of further away.
I didn't say the error is bigger.
I get it though. I understood what you're saying.
Okay. But you should expect a bigger excess if the distances are greater. So if the distances are too close, then the excess is too close to your error bar. So yeah, angles that close are not going to be useful to distinguish between a globe Earth and a flat.
Can we all agree? Can we all agree that the measurements don't prove a globe? As far as just the measurements, we could talk about the least squared and combining the the averages and all that. But as far as the measurements go, just the measurements, they're not all over 180. In fact, well, no, they're not all over 180, and they're some are more and some are less. So the measurements don't prove a globe.
Right.
They
So
can't
actually,
use
like,
that to prove a globe.
if you consider the margin of error even as wide as they want to put it, what they're really doing is measuring a flat, perfectly level, non-moving Earth over and over again with varying degrees of accuracy.
Yeah, what's
It's
in it?
within like a degree of 180. Sorry.
Yeah, I mean, when they do elevation angles, I mean, they're using horizontal. That's literally said they're using the horizontal surface distances. There's no curve to it whatsoever.
There's a
no.
meme.
Well, that's. Sorry. Go ahead.
Here's a meme that we made from the measurements from that survey with the margin of error. It's helpful. They're all below 180.
Right. Yeah. The horizontal
Look up.
angles are angles that are pivoted on a vertical axis. Like it.
There we go.
Doesn't require a flat surface. You can do that in any surface as long as you're pivoting your angle on a vertical axis. That's how you get an azimuthal angle.
But
a
azimuthal
Where'd you show
requires
that,
horizontal
Shane?
though.
Where can I see that meme?
I've
I
got
don't know.
it.
I put it in live stream.
I've got it on now, Brian.
Cool.
I'm showing it to everybody. Yeah, it's in the live stream chat, live stream commentary. But yeah, look at that.
You just add the
179.59.
degrees and the minutes.
You added them up. That's right, man.
Oh, what about the seconds?
We added everything up. We added everything. That's the full sum, man. If you want to add them up and get something different, let me know.
Wait, how is that the full sum if there are no seconds there? I mean, the seconds clearly add up to more than one arc minute, and you have one arc minute missing to 180.
A second being one 3,600th of a degree. That second, and then the decimals of that. So
Okay.
36,000th of a degree. I'm just messing. with
Okay,
you.
Yeah, you already
okay,
have
Bacon.
like 107.
It's
You have
degrees,
already have
minutes,
like one.
degrees, minutes, and seconds, and then
Okay.
hundredths of seconds, right? That's the specificity of the measurement.
How
Yeah.
The
much?
total is
But
that
I-
the total's in degrees anyway, right? So
Yeah. How much?
Yeah, but that's
Curve
those
which-
are just fractions of degrees that
How-
are missing in the sum.
How much curve would you expect anyway in a fraction of a of a second?
Exactly what they corrected to.
Uh,
Because
I don't think
they
so.
started off
go
on the
in-
East Coast looking at the star on the East Coast and the angle, and then I'm sure they lined that up with the almanac, and then went to the West Coast and lined up with the star there. So what are they going to correct to something that doesn't make a good map for them?
don't look at it and use your gut instinct. You don't react. Add them up, dude. Add them up.
Well, fortunately, I can do that right now, so just give me a second.
We will certainly do that.
Over ball, I promise. Yeah. That's that.
Bacon can.
Yeah.
Go ahead.
No, go ahead. It's fine.
I was gonna say bacon can add one hell of a digit, man. Watch out.
No, I trust Bacon. I think they'll come to the same conclusion that we did, and I'm not going to tell Bacon that these numbers were calculated by another glober. So.
Oh, even I mean, it can be a glober. The glober still missed the seconds.
All the measurements are within like 1 arc second of 108 degrees, give or take, plus or minus. So what they've done is say all the ones above are the ones showing spherical excess, and we'll throw out all the others. Then we'll create this mean average, and we'll form a correction formula based on that, and literally push them all over. It's the goofiest flat Earth proof / fake globe proof that I've ever seen.
Mm-hmm. They're literally showing
So-
horizontal measurements. Literally.
Oh, I can't copy and paste because I'm doing this in separate computers. Yeah. But that
No.
first sum, it's add up to it is below 180, but it's
Right.
like 179.9995527.
Even
That's
worse.
why I wanted to give a shout out to
Oh,
Dave Johnson, man. Go ahead.
Yeah, that's not missing a whole arc minute as that sum shows. It's missing 0.17 arc seconds. It's a lot less than a whole arc minute. So
So-
that
so
sum
flatter.
is wrong.
So flatter, right?
Yeah.
Oh, flatter compared to like a hyperbolic surface. Like on a hyperbolic surface, you're gonna get smaller than 180.
Don't forget, Bacon, that error margin is, up top. So check out the meme up top, do the calculation there, and compute that it's like 0.87 error margin. So if you're going to argue that the spherical excess is less than the error margin of the measurement, I don't know if that's a strong argument.
Oh, but if that's the error margin, then there still can be excess because it's in the. If you add the error margin in the other direction, you can still get excess out of that.
Sorry, guys. I pressed the wrong button.
But my point in making the video were to show that because it's crammed down my throat that every triangle on a sphere has to be more than 180, and that's what we measured. We realized that every single angle in this survey across the continent measured more than 180. My whole point was is that a false statement? I understand y'all are going to have a rebuttal.
This is what McToon did, and it's so sneaky, right? Like, so you see the meme I put up, you see the columns. We added up the left, the actual measurement. The one in the middle is their corrected, quote, corrected measurement, and they will always equal 180. They all only equal 180. Like, they are all above 180. So when they say no measurement is below 180, he said he was specifically referring to this arbitrarily corrected measurement column. Anyway.
Mm-hmm.
Yeah. Well, I think when you, like, let's take the example of you're taking some section readings. And it turns out your section has a index error of 2 arc minutes. So every angle you take a reading of has an extra 2 arc minutes there.
Or minus.
That you wouldn't use. Yeah, you wouldn't use those 2 extra arc minutes in your calculation. So you're not going to use the raw readings. You're going to correct for them. You're going to correct for dip. You're going to correct for refraction, and you're also going to correct for the index error.
Sure.
So once you correct for all those, you get a more accurate value, not a less accurate value. So it wouldn't be like if I'm saying like every time I read that star I get this specific angle, and you look to the raw readings, you say no, the raw readings say something else. Sure, because they're less accurate, they're missing corrections. It wouldn't be unfair for me to say that the angle that I said because that's more accurate than the raw readings.
That's a really big position to take, Vic, and I love you, dude, but that's crazy, right? That's like saying I got a measurement to the star, and the margin of error of my instrument is 1 second. So if I add that to it, I actually get a different star, but that's okay because I'm correcting.
No, you can get the 2 arc minutes is error of your instrument. So you know that the raw readings are wrong by 2 arc minutes. That's not a globe thing. That's something you take from the section itself, right?
But
And
you
it's a more
verify
accurate
that.
value.
You're good with verifying that McToon and Fight the Planet Earth and all their claims that the actual measurements, let's talk about just what we measured in the theodolites, do not all add up to over 180. Is that fair to say?
No, it would be fair if you said the raw measurements. I'll be happier with that. I think like if you're saying actual, a lot of people would.
I'm not talking about the least square. I'm not talking about the least squared adjustments. I'm talking about the raw measurements. So when they make that claim,
the raw measurements.
Make that claim that it's measured, not flat. It's correct. So as long as we get the argument in the right place in the weeds where the corrections are, then we're having a fair debate. And McToon was dead wrong and owes Ryan an apology of some sort, or at least a clarification, because not only did he shove it in his face in condescending fashion, he bitched about him paying attention to detail and getting an attitude about Ryan not knowing this stuff and him literally giving everybody in this debate false information and not the full story.
No, I think that's just
I have a
misunderstanding of terms. Go ahead.
For anybody with the balls, right? Why do you want it to be a globe so bad?
That's not the case for me.
No. Just anybody. Just please answer that as best as you can. Why do you want it to be a ball so bad?
That question carries an assumption that we do want, which is
I technically don't. I would. I think it'd be kind of cool if it wasn't. I think it'd be kind of extraordinary.
Well, I think the question.
Hold on a sec, guys. They can't really answer that question honestly, because if they did answer it honestly, because I remember when I didn't want to admit some things in my life, everybody does, and but then admitting that I was wrong, especially after such vehement narcissistic presence, calling people names and coming after us. We didn't barge into your house; you came to us, anti-flat earthers. But anyway, besides the point. I remember how hard it was to admit I was wrong. So you just got to keep doing it, kiddos. That's life.
Yeah, I think the
but I don't
question.
think my answer was dishonest at all, though. That's my true position.
Yeah, I think the question would be is why would you guys feel the need to have a problem that other people have a different belief than you?
Or just think you're wrong.
These guys don't, to be honest, right? These are some of the nicest Globers that you'll ever come across. Anyway. We got demons trying to bacon in here, yeah.
But notice when I ask that to a lot of people that believe the globe, they say either I don't know or something along those lines. They never say because it is, because they can't prove it.
Maybe ask them, would they be willing to be convinced of the opposite position, or are you too closed-minded to even think about it?
Well, when they hear flat, it's like a whole nother construct starts developing.
Right. And then not only that, in this cosmology, people will just, they don't believe that it's necessarily flat, so it's speaking past each other at that exact moment to begin with.
So they don't think they're lying when he made the claim that every single angle was more than 180. He just judges that there's a ball, so he knows they got to be without even looking into them. Or do you think he looked at the information and just omitted the ones that were less than 180? Either way, man, he owes some kind of response or clarification to mine. I think he was writing an apology for.
What I was trying to point out with the Saxon example is that that's not necessarily a dishonest omission. Like if I give you elevation angles to stars, you might want me to mention that I subtracted the index error, but it wouldn't be dishonest for me not to mention that, because that's the angles you would want, the more accurate one, which is the one that you remove the instrumental errors.
So if I did it on an AE map and all the angles, they didn't cross properly, they were a little off. Even over long distance, just a little bit off, but none of the lines when we compared them to each other, they didn't cross at a perfect position, like the measurements in the transcontinental position. But that's the actual measurements, though, right? Even though they didn't line up exactly with each other, maybe that's just how the Earth measured. Maybe we haven't put it all together yet. You know what I'm saying? But they're all damn close, and it is a least squares method they use to put it all together. Which to me, when I hear least squared, I hear the word average. That's my opinion.
Yeah, the least square is how you get a value that minimizes the square of the errors. I mean, this I think it's going to get too specific. So never mind.
Well, Bacon, did you see McTune's argument last night? Do you stand by what he did? Do you agree with him?
I didn't hear you debating last night.
Oh, man.
Yeah,
I got a question today. People were asking me they want me to what's the because my comment the other night was when they asked about the moon, I said I don't know. All I know is God placed it there. And while I challenged them to, then provide evidence to me that God didn't place the moon there. Instead, what I'm getting, instead of then providing me the proof that God didn't place the moon where it is, I get, why don't I provide the evidence that God did place it there? You understand? So it's like reversing the burden of proof, because they can't prove that God didn't place the moon there. So they would just go against what I said. So they would make a claim and not provide evidence, instead try and reverse the burden of proof. And that's what I've seen a lot on any arguments we get for the globe. I mean, when we try and bring up a subject, you guys try and just reverse the burden to us to try and replace the fact that you guys can't provide evidence.
Right. So here, let me think about that question.
Like telling us prove Santa Claus doesn't exist. Oh, sorry, dude.
No, yeah, that's kind of the same line. Like, can you prove that magic farting pixies didn't place the moon there?
No, that means it happened.
Well, see, what I think was happening way back then with all these philosophers and mathematicians, I think they were depicted as these super smart guys, right? Obviously. And then when people kept asking questions, they looked around their their workstation, they saw a ball, they started doing calculations for that, and then they said, "Here, play with this. Stop asking me questions."
I like that. That's funny.
I mean,
oh no,
yeah.
this is a key point. So Bacon, when MC Toon, I'm gonna quote him as best I can. I apologize if I'm off by a word or something, but he says that every triangle in the transcontinental arc of the parallel, every triangle they measured was more than 180 degrees. Okay, if he's seen that, so do you think? Two questions. Do you think he's seen and bothered to add any of them up that were less than 180? And if he did, what's that say to you, sir? You don't think that's a little bit dishonest? Is saying that the actual measurements were all more than 180 when the actual measurements were not more than 180. So do you think he just didn't see them and is being dishonest by omission, or do you think he's flat out lying?
No, I mean, as I said before, I think he looked into the corrective values. And that's what he's referring to. Not the raw. I don't think he was
So when
referring
he
to the raw
reamed,
rates.
so when he reamed Ryan for not paying attention to the details and reamed him literally on the debate, when Ryan was being civil and nice, you know, he never caught an attitude, and McToon's getting beat face red telling him to pay attention to the damn details. So then it was in fact MC Toon just didn't look at the detail then. That's what you're saying?
Well, I have to watch that debate between them, or that piece to see,
Well,
Uh,
so
to evaluate that.
Sorry.
yeah, I have to say, man, he put it on his website. He did a calculation. He's well aware of exactly what you said, Luigi, but his weasel out of it is that, you know, I'm going to go to the middle column where we pre-corrected for make sure that they're all above 180,
Well,
and then we're going to say that none of those are below. I
You
think
did the
that's
same
what-
thing with me with celestial navigation. I mean, how long was it going on telling me you don't do triangles and triangulation and navigation until I give all this citations? Now he just acts like he's never said it before. You know, that's just
Yeah, I
how
mean,
he
yeah.
is.
Sorry, go ahead.
But sorry, guys, Andrew just came in. He said he just wants to come in for a minute. Would you guys mind if he quickly gives his statement?
Hi,
Yeah,
Andrew.
I would mind greatly. I'm going to ask that he doesn't speak it. I'm just kidding.
Oh, he
no,
just
he
left.
Oh,
He just
no,
left.
Sorry.
Oh shit!
It was just a
He
joke.
actually
Oh, he's
wanted
back.
to-
He's back. He's back.
I know you.
He's back. He's back. He was only joking, Andrew. He was only joking.
What's up, Andrew? Nice to
Welcome, man.
chat with you finally.
Hey, before, if he's not responding, let me just, I used that first triangle in your screenshot sheet, and excess there is diverging from the goal prediction by 0.62 arc seconds, which is within the margin of error. Just so you know that. I'm gonna do it the second. So,
Yeah.
give me a
Find
couple
me a
more.
spherical excess measurement that exceeds the margin of error next time, though. And find a couple.
Right. Find you a flat Earth point. Okay. Give me a second.
Yeah, you're good at that, Bacon. That's why I like you.
Let me see what I can find. 30 seconds.
And one more thing, I would actually love to see the actual papers or whatever you want to call it, whatever they were writing on, of the actual arithmetic that was being produced by some of these philosophers. Because just like ancient scripts and scrolls, people interpreted them differently. Therefore, there were variables and symbols that people didn't understand. So they were basically kind of told, well, what these symbols were meant, and that kind of indoctrinated a lot of people. Eventually getting lost in translation to control a group or region.
And let's make this crystal clear with everybody. They didn't measure the distance in every single one of these triangles. Okay, they did a handful of them. Every so often did they measure every side of the distance. So the majority of the triangles they just measured one side. And we're talking about doing measurements over 30, 40 miles. Next time you're driving down the road, just look at all your turns. that's a monumental feat to claim accuracy. So there is a margin of error, but yeah, they didn't measure all the sides. So if the Earth is flat, put your flat Earth hat on for one more second, Bacon. That if they're just doing like every 10th triangle, every 100th triangle, even or every 5th triangle, and they're all using calculations instead of measurements, and jotting it down and correcting for a globe, then we wouldn't expect them to line up perfect when we made it to the triangle and measured all three sides. We would expect error, wouldn't we?
Hello?
Hello.
Okay.
I had a hard time hearing the question. That was my bad.
No, I'm saying if they only did calculations for 2 of the 3 sides of every triangle, and then periodically, like let's say every 100 miles, every 200 miles, measured the full triangle, then we would expect error.
Adam Meakin's actually got a very good point here. Hi Adam Meakin, thank you for coming. He says, does the trilateration used in GPS produce triangles or anything other than 180 degrees?
Well, the distance you get from GPS, at least they produce the excess you would expect on here, because it do give you the hammer sign between the coordinates.
Yeah, well, Habersign presupposed the globe.
Exactly. So if the distance you get from GPS match Habersign, so they're not going to match a plane, they're going to match a globe.
So I could apply Habersign to my front yard and make it a hemisphere, basically. Right?
Yep.
No, those distances are not going to match.
Yeah, because you've already taken the data and you're translating it to the Habersign formula to give it a radius.
My front yard's going to be off by like a millionth of a millimeter, basically, right?
Oh, you can use. I'm not sure if I understand the question though. But though you can use. I mean, this is a bit different than the topic of spherical axis. Still related, which is using the azimuths of stars. The azimuths you get from stars give you not just a couple arc seconds, give you several degrees of excess.
Where though? What about on the horizon? Like they just throw them out the first 30 degrees, especially the first 10 degrees, 20 degrees. I don't even see the stars intersect the horizon. I've never in my life. I don't want to say I've never seen a star intersect the horizon, but they just disappear above the horizon.
Not talking about elevation, and we can, if you want, we can only pick angles above 30 degrees.
Then it's elevation.
30 degrees, we worry about the elevation, not with the azimuths.
Adam Meakin says he'll come in 5 minutes and he'll discuss the GPS with us. Because he says it doesn't use any Habersign. Only the GPS coordinates apply the Habersign.
Yeah, I think they use ABC method.
Mm-hmm.
No, I mean the coordinates you get from GPS are ECEF coordinates. You can switch between ECEF coordinates in latitude and longitude. But in any way, if you switch them to latitude and longitude and you want to get the distance between a pair of coordinates, you're going to use Habersign. If you're dealing with ECEF coordinates, you can get the distance between them like using Pythagorean, but that won't be the distance over the surface. That would be a straight line between those points. Then you have to
like a
have
chord.
that take the.
Should be making a chord.
Sorry, go ahead. Yes, exactly. So if you get the distance between two ECF coordinate points, that gives you a chord line, and you can turn it into a distance over the surface by halving that, take the arc sign, and doubling that again. Which is the exact same thing as using Habersign. Gives you the exact same answer.
Okay, that's interesting. So have I killed him the debate now?
Well, it's not exact, it's not perfectly exact, but you're talking about
It is.
Brad.
Here, I got a question for you guys too. Does anybody still have one of those old GPS that shows you the, in quotes, satellites?
I've never had one that showed me satellites.
Does anybody still have one of those?
Not me.
Because I do. It's made by Cobra, okay? And if it were a ball and all those satellites were in free fall at 17,000 miles an hour, those GPSs would never work.
Mhm.
You'd never be able to triangulate one. They'd be moving too fast and they'd be gone. So yeah,
Yeah, but I mean, we even had
but those
Professor
still
Phil,
work.
we even had Professor Phil Bell that had to at once. I think it was on Brian. Brian, you actually put it up at a stage where Professor Phil Bell conceded that they had to place the data in for the satellites to give them that they're as if they were a certain distance on a
Yeah.
globe after they have the
That's what
data
I-
measured.
That's one of my favorite questions to Globers would ask them, like, how do GPS satellites know where they are? Yeah, okay, how do they know? They got to be told where they're at. And
They're
if you
talking
tell
to
them
each
that they're
other.
curving around a ball, then sure.
Yeah, they're all talking to each other to maintain a grid and calculating for it.
No, they don't talk to each other. They talk to the ground. And I wish they did talk to each other.
I might be wrong. I was under the impression that they were, talking to each other to help correct for time dilation and things like that.
Time dilation. Sorry.
All that information is routed to you through a couple cutoffs, so you don't get the direct data. It goes through a couple places. I'll post a video in the live stream context, giving the detail on what happens to the data and a little more about it. I don't know if they've updated any of this, but this is what I learned in my study.
I remember when me and my wife were going on a honeymoon, and we were going to the places, and at one stage we came to a place where the GPS didn't pick up anything. It was literally showing me driving in the ocean, and we were in the middle of the continent. So tells you, how does the GPS pick me up in the middle of the ocean if we're driving in the middle of the continent? So how's GPS very accurate then?
You have a direct,
Well,
you have a
you
direct
usually-
line to the satellite.
You usually get an error bar from the GPS itself. Like the receiver has an estimated radius for where you would be given the location that it's guessing. Do you remember what was the?
But remember,
the
GPS works on
error radius for
trilateration.
when that happened.
Remember, the GPS works on trilateration, so it's three different pings from three different GPSs, and it's not
Four,
supposed
actually.
well four, and it's not going to pick you up in the middle of the ocean if you're in the middle of a continent. That's the whole point.
Right, but for example, if you only got signals from 3 satellites at that time, then you won't be able to trilaterate properly, and it might throw you completely off of your location. But that's going to be part of the output of the receiver. The receiver is going to have a huge error bar if he's doing something like that, like dealing with only 3 signals, for example. And that should that's something that I'm asking. Like if you remember the radius of the error bar for the GPS when that happened, because it could be huge. That's not really a problem. The problem would be if it's giving you a couple meters accuracy and that's happening. That'll be a real issue.
Okay, got another super chat from Godzilla37. $7 super chat. Thank you very, very much, Godzilla. Shut it down, guys. We have our globe proof finally. Thanks to Duper, we now know it's a globe. The proof maps. 2-dimensional maps is now proof of a globe, guys. Thank you very much for the super chat, Godzilla. You see, the thing is with the GPS, if it's supposed to be even with a margin of error, I mean, Africa is quite a big continent. It's not a small continent. It's not going to push me out, let's say 2,000 to 3,000 kilometers out into the ocean with a margin of error just because it doesn't pick up one GPS signal.
Oh, you need 4 to properly find your position, and
I'd
usually
say
it takes
let's
most-
remember. Go ahead, Vic.
Yeah, oh,
You need-
actually,
need
thousands
4,
of
man.
How many kilometers you said?
At easy about 2,000 kilometers. That's a difference.
Billions.
Yeah, that's a couple of degrees of your coordinates.
Yeah,
if you're only
but you
picking up
understand, if
3
you
signals, you
3 signals is
Yeah, if
more
you-
than enough to pick up that you're not 2,000 kilometers away into the ocean.
not really. Given the speed of the signals, you can't get your position with only 3, because you don't have at the accurate time of between when the signals were sent and when they reached you.
Then you're just providing us
so you
evidence
don't
that
like-
it's only based on line of sight to relay stations then.
Sorry?
Because then you're actually just making my point where you said GPS is only based on line of sight to relay stations or satelloons.
And what he just brought up, the relay stations, the ones that they use on job sites and stuff, where they get the pinpoint accuracy, they're using stations that are in certain positions, and if you look, you can find out where they're at. And they call them satellites, like the receivers
I'm aware of that.
up on buildings and on towers and all that. They call them satellites as well.
Yeah, I'm aware that you can have any device that is sending you their ECEF position can be used to triangulate your own position.
So if we're going to go for construction grade accuracy, like when it comes down to slope and making sure you have the minimum, and to get to accuracy, we're using land-based. Well, here's another point I wanted to make. This was a hard one for me to grasp, like way back on Brandon's. Like I fought it tooth and nail. That like the difference between when we were trying to think of ways to prove one way or another and demonstrate it. So the difference between the arc distance and the straight line distance over 1 degree, like 69 miles, is like just barely under 10 feet. So you're talking about 69 miles, you're talking about driving the speed limit for an hour, and the difference in distance between a flat earth and a globe would be just a handful of feet, bro. That's insane. How could we really know? I don't know, man. To me, you putting humans on a pedestal, they could measure that accurate over that distance.
Oh, you don't need to be that accurate.
I think that a better way, instead of using only 3 points, would be maybe 4 or 5 or 6 points, and then measuring each point to where you are and see if all of those are the same.
I mean, they used to have LoRa and C that worked perfect. I mean, those are all ground-based position relays.
Yeah, and instead of upgrading Loran, they just basically upgraded Loran and called it GPS. To me, with a little help of I don't know. There's a few different possibilities.
I mean, now they're going to LoRa and E, which is going back to ground-based positions.
So how would ground-based positioning systems work when you are at sea then?
Easy, they got buoys. That's why there's some places in the Atlantic that you can't pick up any planes.
Yeah. Also the LTE, the cellular network in South America, the whole continent of South America only involved I think it was a dozen or a little less than balloons to cover the whole continent.
So I just got to say this debatable D.
Sorry,
debatable D asked me, how does DSTV work? Yeah, it points to a tower. Yeah, where we are, we got a mountain that's over 2,000 meters high. Or is it 2,000 feet, whatever. Anyway, it's double what Table Mountain is. And they have dishes literally pointed at a relay station on top of that tower. You can't see it where we are, but all the dishes are pointed at that tower. That's how your DSTV works.
I was just thinking about the buoys though. Like, do they also have data transmission lines strung up to them, or?
Well, we lose GPS out over the ocean, and as far as flights go. But where would we expect the most error at? We would expect it the further we push south. And if you go and look at the GPS data for the shipping containers and stuff in the southern oceans, you'll see that they push some of them in the middle of the continent. So you supposedly have ships sailing in the middle of the continental Antarctica on a globe. I mean, that's where the errors just start becoming so apparent.
Yeah,
it's ridiculous.
I mean, have you guys not noticed Have you guys not noticed how some?
Did you say you lose GPS over the ocean?
Yeah, I mean, how do you guys not
So
notice
how
that
does
planes?
that happen?
Yeah,
If there's satellites above you.
that's what I'm saying. How have they not noticed that why you get planes that all of a sudden vanish over the ocean? It's because they didn't have any GPS signal to them. Hello, how does that work without satellites?
But there should be thousands above the plane.
Exactly.
Wait, what do you mean?
It's
The
nothing
ships
here.
Even
well,
the
no,
flight,
we lose a plane.
even the flight
completely
planes.
lose the plane.
Yeah, even flight planes.
Microprocessing units that deflect certain radar systems.
even flight plans,
Free scale semiconductor.
even flight
The radar
plans,
was jammed.
even flight plans, they have a certain window that as soon as they leave the GPS navigation's pickup, they have it that it shows on the computer just as a average that it's still going at that same altitude and speed and traveling there, and when it gets to the right pickup, then it picks it up again. But on the computer it's showing that it's still picking up, but it's not picking up anything. It's just the computer literally giving the average of what it's been picking up on the flight.
And if some shady shit is going on that aircraft or wherever it's going is some shysters, well, then they'll just turn that off.
Mm-hmm. I mean, how much
Can I get
planes
more
have?
information?
I mean, how much planes have just literally vanished in the middle of the ocean? There's a reason for this, because no satellites could pick them up because there's no such thing as satellites.
Mm-hmm.
The Malaysian flight
Oh,
was the
don't-
best one because of who was
We
on
have-
board, what they were carrying, and who ended up being the #1 shareholder of Freescale Semiconductor when that plane went missing. Rothschild.
Interesting.
Well, we if you go to flight radar, you can see plenty of airplanes over many pieces of the ocean. They don't keep disappearing. I don't see what you guys.
That's what I'm
mean.
saying. They
Well,
keep.
you
guys
sound like a
elaborate
coincidence
a little
theorist,
more?
man.
Can you elaborate a little more?
They
on the-
those are set into where they're at what they call like dark areas where it can't pick them up. It still shows on the radar, you can say, that it's picking them up, but there's no it can't pick up the plane. It's just making an average on describing the plane is going there, and it's not actually picking it up. That's why you get planes vanishing out of no thin air. Like all of a sudden, oh, this plane should have made it, yeah, but there was no plane, but it was showing the whole time on the radar it was still flying. That's why you get like the Malaysian Airlines, you see all of a sudden it just vanished out of nowhere because it still showed them flying. In the meantime, how do you know they were still flying? They weren't.
Can you go with a little bit more details on where this information is getting from? That you have the planes in certain spot not appearing, not getting picked up by.
Yeah, it's an approximation, man. It's an approximation.
Satellites
Well-
don't pick up airplanes. The airplanes have to pick up the satellites. So you're saying that you're saying the logs of the airplanes don't have the coordinates.
I wouldn't say that. I'm not 100% sure, but I'm saying if there's errors or any of that, it's possible. But I'm just saying that for them to lose an entire flight full of people, that just put Rothschild's hands on the freaking the patent. I mean, are you a coincidence theorist? I mean, can't you put two
No,
and two
I'm not
together?
claiming coincidence. I mean, first of all, I'm asking to take a look at the information before I say anything about it. But missing an airplane on radar isn't necessarily related to the GPS system of the airplane itself not working.
No, I'm talking about losing an airplane on everything.
Everything,
GPS,
yeah.
radar, like they totally couldn't find it at all. It's gone.
It just
Yeah, but the
vanishes.
GPS is. Okay, but I'm asking for the perspective of the airplane. If the airplane still can, like, if you're picking up the airplane, then you have to communicate with the airplane. That's not related to GPS. What GPS is
I
doing
see
is
what
giving
you're
the
saying.
airplane.
Sorry,
You
Satellites-
don't ever have to communicate with an airplane that is doing shysty things.
A satellite doesn't
You
need
don't
to.
Yeah,
always
but
have to have
in order-
communicate.
A satellite doesn't need to
To
communicate.
pick up in any system, you have to interact with it. Like,
No, that's false.
like radar.
A satellite doesn't need to communicate with someone to be able to pick them up.
You have to interact with it.
How do you
Yeah,
get
you just
satellite?
have to get a signal. All you have to do is get the signal sent from the satellite, and that's just the location of the satellite where we tell it that it's at according to the model, and then the time it takes for the signal to get to the receiver. That's it.
I mean, look
Right,
at
but
it.
the
When you take
airplane
off, yeah.
Use that to get its own position. That's not gonna tell other people where the airplane is. It's gonna tell the airplane where the airplane is.
Remember
if
when
you're
you-
I
saying-
believe
if
the
you say
airplane
other
is where it
people-
is, according to the model.
It's estimated. It's estimated using some math. Okay, so they say, okay, well, this plane flies 500 miles per hour, and it's
I'm
going
understanding that.
12,000 miles. There's an estimation that's happening where, okay, at this time the plane should be here. So that's what they give you on the map.
Exactly.
They show,
I'm
oh,
not
the
asking
plane is
that.
here. But you don't think there's room for air there?
That's completely unrelated to what I was saying. I'm asking for the information that the GPS isn't working in some spots. Not that you don't know where the airplane is. If GPS isn't working, then the airplane doesn't know where the airplane is. Not other people checking
But
its
that's
route.
false. An airplane gives out a.
That's a different. That's a
An
completely
airplane
different thing.
always. An airplane is always giving out a
You
signal.
need to go look up what semiconductors do and like adaptive, it's called ADAPTIV camouflage. You need to look up some of those because those can just deflect any form of system detecting them.
Yeah, but
That's
I
what they're
mean,
used for. That's what free-scale semiconductor was for, to basically cloak an airplane
yeah, but I mean, what?
beyond radar.
But let's just look at commercial planes. They literally give off signals with the tracking. They got trackers. Every plane has a tracker on them. So why would they lose tracking over a certain part of the ocean if satellites are still supposed to be tracking them? Because that's the satellite's job.
Well, who said it? The satellites are tracking them. I mean, if you're talking about GPS satellites, the GPS satellites don't see the airplanes. Just the
I believe the
airplanes.
planes. I believe the planes know where they're at, Bacon. I believe the planes know
Yeah,
where they're
the
at.
planes
I'm not saying
do.
that they don't.
So we're no longer talking about. We're no longer talking about GPS then, right?
Kind of. Yeah, we are bombarding you a little bit, to be fair, guys. But hold on. Let me make it worse. No, I'm just kidding. Somebody just said that the GPS, like planes, don't get GPS signals. Who said that? I didn't know that.
That's Bacon said that.
Say Flats, Adam's come in if you want to hear from Adam.
Oh yeah, Adam's in. Oh, he's dropped again.
Oh, he just chopped out again.
I
Oh,
said
Adam's
what?
in. Adam is in.
I
Adam
think
is
he's
in.
in now. He's back in.
Hey Adam, how's it going, mate? I think he's got issues with his sound or something.
Yeah, it's going sorting out.
Yeah.
Because I even know, even with ships and stuff, if you go to certain parts of the ocean, you can't pick up any satellite GPS at all.
Yeah, I was looking for this. I haven't actually found any information saying that GPS doesn't work over the ocean, just it's accurate within 5 to 30 meters.
Yeah, if you can give us a little more context into that information, that would be great.
Okay, shot. No, you don't need
So
permissions.
let me do this then. Let's say there's a secret island in the middle of the ocean, and there's a signal that you can mask, right? And it sends it to one thing. Let's say one airplane. And that airplane detects that signal that's masked for everybody else. That airplane's going to travel to that signal. It's going to know where it is in relation to that signal. Nobody else might know where that signal's coming from. Nobody knows where that plane is. But that plane is only traveling to that signal. Therefore,
How can only the airplane pick up the signal?
becomes how does an airplane radio waves?
No, I'm asking how would only the airplane pick up the signal? Is the signal being sent in the airplane's direction, or is it being sent in all directions?
Do you know how like a radio works? Like they put it at a certain frequency, and then that thing or whatever transmitting signals, receiving signals, tunes into that frequency.
Yeah, but I mean, anyone that gets
frequencies
close to
can
that
be-
frequency is going to pick that up, right?
Frequencies can be masked.
What do you mean by that?
They could be a frequency could be invisible to every other radar that's out there.
How?
By masking.
Like if you don't pay your bill, like if you don't pay your bill for satellite TV and they cut you off, everybody else gets the movies, but you. I think that's what he's saying. I'm not. This is my argument.
Right. What does that
Thank
masking?
you.
How
That's
does
better
that
way of
masking?
saying
How does that
It's not like
masking
they're
work?
canceling your signal. They're just telling
Yeah,
your
I think
receiver to not accept it anymore.
You know, you can create electromagnetic frequencies that can deter everybody else's frequencies. Okay, so you put yourself in an electromagnetic field and you only accept this one frequency. Everybody else cannot see you nor see the frequency. You become invisible. That's how you make a plane disappear.
Well, how can people not see the frequency? If you tune into that frequency, how you're gonna not pick that up? If the signal is going through you at that frequency and you're tuning that frequency, how can you not
Like
pick
World
that
War
up?
II when they had the planes built out of wood, it was simply to change the frequencies of the radio waves.
And that's why I say you
Isn't
need
that
to
so
go
they
look
don't
up
interact with the radio
you
waves?
need to go look up free-scale semiconductors. You need to understand how those technologies work.
Oh, you're
Because
gonna
you can
explain
deter radars, you can deter frequencies, you can mask frequencies, you can create a frequency that no other person, no other system can detect. That's the point of them.
Frequency is just an amount of hertz. How you're creating frequencies that people can't detect? That doesn't make any sense. Can you elaborate on how that works so it might make some sense to me?
Generating
I think I have some background. I think I have some background.
frequency that nobody else can detect. Well, if they don't have the right tools, then they're not going to be able to establish a connection to you because they don't have that capability. You're doing something on the aircraft that is deterring them from detecting you.
Okay,
Let me bring up
it's a
another point.
frequency. Okay, yeah, I think we're getting to.
Yeah, the possibilities,
Or
there's
from-
no point. I see what you're saying, Guy, and that's fine, but as far as, there's no way for him to really argue that. If they could, we assume, to us, it's obvious they're doing shit like that, but to them, as far as debate, it's kind of tough to debate the possibilities, but that's cool. But if you look at the video I posted in live text context, or live chat context, it's going to show you what happens to the signals and before you get them, how many hands and what hands they pass through. And these signals, the position of these satellites are updated twice a day. So in other words, twice a day, they're not in position that they're calculated to be. And that to me is a problem on its face, and it's not a perfect system, self-maintained, because they have to be, the position of the actual satellites have to be updated twice a day. In other words, they're in the wrong place.
Wouldn't that give evidence then to Satelloons then, Brian? Because Satelloons need to be placed up there quite a few times. I mean, how much satellites does NASA launch a day with balloons? Quite a lot.
Well, we know that they're the #1 purchaser of helium in the world.
Mm-hmm.
Just a head scratcher, if nothing else.
Yeah, it's just weird. It's
So, I've been to the geodetic survey. That we're gonna call that a win. Did you concede, Bryson? I think I heard you concede. I think the image part conceded. Yeah, I think you both conceded, right?
Consider what?
That the Earth's flat and that the data shows that.
I don't remember doing that.
Hey, you heard it here first, guys.
well, we can just say what is horizontal, and then that's about it.
Perpendicular to the surface of Palm.
Perpendicular to vertical.
Great. So, the 4,000 kilometer measured horizontal surface distance. Do you get that? Or do you have the same horizontal from point A to point B?
I'm not sure about that.
I'd say the LIGO place, it's horizontal, but it's not level all the way across.
Yeah, water would have to collect in the middle of it, right? I was going to go measure that thing, and still might, but they put a dam in the creek. But to me, even if I dug down to water level, I could still see its flatness. But they're never going to convince me that I live on a two-dimensional sphere.
But so the evidence is there, you're just gonna ignore it?
Well, I talked about going and measuring it. I'm about 6-7 hours from there. I know where it's at. I used to live in that area. But the thing is if it doesn't match if it matches the water table or the water level, then that means that it's what we think it is and what, to me, common sense says it is. But if it's concave, then they discouraged me from before I went through all the trouble of measuring it. I wanted to talk to the ballers and see what kind of objections they had. I wasn't gonna waste my time, and they all pretty much agreed to the fact of the matter that the tunnel won't match water level because the Earth's a globe, and so in their world it's a little bit concave, just slightly. But then Blue Marble Science zoomed in on the canal next to it, and it's like grown over, which I was willing to clear it out a little. But there's a rock, like they dammed it off in the middle. But to me, would a dam in the middle of it with just rocks affect the level of the canal on either side of it or the ditch? It should still flow through, right?
When you said it's concave, it's actually not. It's perfectly flat all the way across the surface in there. And you can use like a laser in there to verify that.
Wow.
Yeah, I agree. But in their world, let's say Pontchartrain Bridge, in their world, in the middle, compared to the edges, it's about 120 foot higher. If you take a straight line and put it on a globe, it's going to look like a bowl. So if we backed off of the Pontchartrain Canal Bridge, and let's just say a quarter of the way across, and we looked at the bridge and we backed away from it, let's say 6 or 7 miles, on a globe, if the Pontchartrain Bridge was level or flat, then each side would be higher. From the middle to the edge would be higher by like 120 feet. The middle would be up 120 feet, and the dam where it hits the land would be up 120 feet. That's how a straight line works on a globe. It's hard to grasp mentally, but that's how it would work on a globe.
But it's not a straight line because it does. Like I don't actually know the measurements from the water level to the beginning of the bridge, but I would assume that the majority length of the bridge, the water levels are the exact same. But when you get to either side of it, it's gonna slope down somewhat to get to the ground. I don't actually know the elevation height of where they began building it, so there's a little bit of missing information on my end for that.
Okay, I got 2 questions then. How do we have, or everybody says that the Earth's radius is X, whatever it is, all right? How is that a finite answer? That, this is X, this is the radius everywhere on Earth. The radius is based on a perfectly round circle. Like no mountains, no water, no nothing. It's based on a circle, okay?
Yeah, it's
you're telling me that anywhere you go around the Earth, the radius is the same. Where are they taking this measurement from? To what?
No one says that. No one says that that's the same radius everywhere.
Well, they do say it's a pear-shaped, and then they say it's as accurate as a cue ball, like it would qualify for a regulation cue ball, and then everybody else calls it pear-shaped, like the satellite.
Right. So if it's
not
toroidal,
enough
it can't.
for cue ball.
Right.
So if you took all the water out, take all the water off of Earth, you think the radius is going to change?
Yeah, the average radius is going to be smaller.
From the highest mountain?
It'll still be a regulation cue ball, though, right? Make it'd still be a regulation cue ball, even if we took away the water.
No, like, there are
If you
two,
took
there are
away
two, can I answer this guy? There are 2 factors that are being, like, in the regulation of cue balls, there are 2 factors. There's the smoothness and the roundness. The roundness of the Earth is definitely within the parameters, but the smoothness is not. If you take off the water, that makes it worse.
Well, yeah, because then it's not
Wait a minute, go ahead.
a circle. Then it would look like, I don't know, a giant piece of rock.
Oh, it would still pretty much be very close to spherical. Like it'd still be pretty, overall be spherical. Depth of
If
the
you were an
ocean.
observer, we're looking at if you were an observer looking at this Earth stripped of its water, and you were the same proportions that would make the Earth look at as the same size as the cue ball, yeah, it would be almost completely spherical to your eyes. You'd have to measure it until it's not.
Yeah, well,
Are you sure?
currently you can get the local radius from your ECDF coordinates that you get from GPS. GPS gives you a X-ray Z coordinate that is the origin is in the center of the Earth. So if you square those values, add them up, and take the square root, that tells you how far you are from the center of mass of the Earth. That will be your local radius.
Question: How do they know where the center of mass is?
Because that's what these satellites orbit.
So they're acted upon by gravity?
Yeah, orbits are acted upon by gravity. Yeah.
So then they just hit the Earth.
No, they have a tangential speed.
So they're not they're not acted upon by gravity then. Because if gravity's
Yeah.
acting on something, it's going to pull it down here, right?
Unless
It
it's
is
got a
going
trajectory
backwards.
like a bullet. Yeah. It's got a trajectory though, it's not just downward.
But eventually, if gravity's acting upon it, it's pulling it here.
Yeah, they accelerate
And
towards the Earth.
based on the weight of that object, well, it should hit the ground faster, right?
No. So the satellites are accelerating towards the Earth. You're correct on that, if that's what you mean. But they don't get closer to the Earth because of that, because there's a tangential speed. And in any rotation, if you combine the tangential speed with the centripetal acceleration, you don't get it getting any close to the center. That's how, for example, say you pick a piece of a string and attach to a tennis ball, and you rotate that with your hand. The ball is constantly accelerating towards your hand, but it doesn't get any closer to it. It doesn't fall towards it just because it's accelerating towards it. Any circular motion works like that. Like if you take a turn with your car, you have a centripetal acceleration, but you don't get any closer to the center of that curve.
Okay, well then here's the experiment I need somebody to do. I need them to put an electromagnetic field inside a perfectly round sphere, and I need that electromagnetic field to magically stick water to it while it spins 1,000 miles per hour.
You'll be, don't hold your breath, dude. But here's the thing. Let's say a levitating
That's the way to
gyroscope.
prove that would be the actual way to prove the ball.
Yeah, well, they don't do demonstrations, dude. They do
It's a
stories.
straw man. I mean,
If
that's not actually what the claim is, but I don't know why you want that, because it isn't what the predictions are for the Earth or the globe or anything.
Let me run this by Bacon. Bacon, see, take a levitating gyroscope, one of them toys, where they're just levitating above a magnet. And so the theory was that if we put that in a little vacuum chamber and we spin it up, that it'll spin forever because there's no friction. There's no air friction, but it didn't run for barely any longer than it did in just in open air. And so y'all would say that that's because of like friction. So wouldn't the ISS suffer from that?
Due to the rotational pulse of the gravity that it slows itself down.
Yeah, the ISS on its own wouldn't be able to orbit the Earth forever. You're right, there is some friction on with the ISS, and you need some maintenance of its orbit from time
What's
to time.
making it? What's tidally locking it though? Like, why is the cupola, which is like a definition of a dome? Why is like a dome facing back to Earth? But why is the cupola? What's adding the energy to keep it tidally locked to the Earth, where it's always looking down at the Earth? What's making it turn
I
constantly?
don't think you need energy for that. All you need is the rotation of the ISS to match the period of the orbit of the ISS.
Okay.
just
Okay.
like
Then what's taking? Fair enough. What's taking the energy? What energy is stopping Earth from turning around the sun? When it orbits the sun, it maintains the same. So one of them has to take energy, either the one that's staying tidally locked, or the like say for the moon, for example. So is the moon like ain't that part of the orbit? How the moon stays? That's considered one spin, right? The moon doing a full trip around the Earth in your model.
Right. Okay. It takes energy to tidally lock something that is not already tidally locked. So, like currently, there's no energy being spent to keep the moon tidally locked with the Earth. It's only when the moon is not tidally locked that takes away energy from the moon and from the Earth's rotation. So, like if you would go back in time before the moon was tidally locked, the Earth would be spinning faster, and the moon would be closer, because it had more energy there that was taken off by this tidally lock. But once you put the ISS, sorry?
No, that's a better answer than the last one I got. The last answer I got was that there's special gyroscopes on there, and I was like, well, that wouldn't make sense because if a gyroscope maintains its rigidity in space, then it wouldn't be tidally locked to nothing. It would maintain its position. So 180 degrees later, when the ISS was on the other side of Earth, it would be facing. If it's going by a gyroscope, then it would be facing away from the Earth. But that's a better answer. I'll give you that.
Yeah, I think they do have the gyroscopes, and they can change, the angle of the ISS using those.
Exactly. I think the gyroscope would be just like a reference. So if the ISS is rotating around the Earth in the same period of its orbit, then if they have a gyroscope as a reference, that gyroscope is going to be spinning in the opposite direction for them at that same rate. So they would be able to adjust if they're not exactly rotating as they should using the gyroscope. I think the gyroscope was just going to be a reference too, not the whole map.
I thought the gyroscope was there were several gyroscopes to help with angle and all that.
Did you just say too that the ISS undergoes friction? Did you just say the ISS undergoes friction?
Yeah, there is atmosphere that it goes through, very, 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 very light particulate.
Well, any form of friction, and that thing's traveling that fast, it would rip apart.
Yeah, if it had like the density of the Earth, like even at like the top of Mount Everest, right? If the ISS was traveling through even that dense of atmosphere, yeah, it would rip the fuck to shreds. But it's near vacuum.
But that makes me think of like your globe, your narrative is that the inner core, it changes its rotation every 70 years. So it spins in one direction for 70 years, then slows down and spins in the opposite direction. Wouldn't that make change your magnetic poles?
The magnetic poles do change, but it also doesn't stop and spin the other way. It appears like it's what was the term? It locks it. I don't think it's actually stopping at any point.
Because it has to stop if it has to start rotating in another direction.
Yeah, I don't know the exact explanation, but when I was looking into it, at no point did they clarify that it actually stopped. I believe what they literally said was it doesn't actually stop, and then they went on to explain what it did, but my dumbass can't remember.
I don't blame you, Demetrius. It sounds thoroughly stupid. Like it probably gets hard to keep the nonsense straight, Because with the dynamo effect, which they're claiming to create the magnetic fields, if it's going to slow down or change direction, it's going to totally make everything chaotic with the magnetic fields. They already have a supremely flawed dynamo model with many problems, right? Right off the bat, the magnetic field lines in the south don't mirror the north. It's completely different as a pole because it's flat, right? So that problem is one of many problems.
They're weaker. It's weaker in the south, which is what we would expect if it's emulating from a center position.
Mm-hmm.
Exactly.
Does the ISS always take its same path?
Yeah, so here, I have a GIF of the ISS that I'm trying to downscale because I guess your server got nuked or something, dude, because you're at minimal boost, so I can't put 6 megabytes. Anyway, the image I just put in is the left hand is the ISS path over flat Earth.
Sorry.
And the middle is the magnetic fire itself.
Sorry.
And the ones on the right are geostationary lines from the geotechnic model, showing you what Venus and Mars circular orbits look like, and then the same ones up top. So the new theory that I think Wissett was kicking around, that I'm definitely on board with, is that the ISS follows the path of the magnetic flux lines on Earth, and they do some sort of electrostatic tethering to get up there, to get stuck, and it gets stuck in this path, which literally is as predictable as the wandering stars.
Sorry guys, I just want to quickly, Faciality, thank you for the $5 super chat, sorry I missed it. Once you awaken to truth, seeing an image of floating globe in space with water not falling off of it is absolutely absurd to think that's reality. 100% agree. Thank you very much for your super chat, sir.
So Shane, the thing you're talking about right there, I'd be interested to see if the astrolabe's progression looks the same, or if, because if both of them follow the exact orbit, you might have a case there, but I don't know.
So essentially they would be tethering to the electromagnetic field of Earth.
Yeah, right. That's exactly. And that explains the crazy speed that they say it goes at, which I'm not refuting anymore. It doesn't explain why it looks like a fucking TIE fighter.
Well, if
but-
you think about
I
it,
mean, like,
if you think about it, it could
Do
just
you
be
think
like you
maybe
said,
it's-
super fluid up
Maybe
there.
it's depicting the toroidal field instead.
well, no, that's the same. It's one and the same, right? Like the 2D representation of the toroidal field in flux is literally the magnetic field lines. That's the flower of life pattern. It's what.
It looks like
That
Arcturus.
spiral.
Think
that
of-
spiral that goes from the outward inward.
Yeah,
Think
it's
of it as
easier to
like-
see it in motion. I'm trying to get the
Yeah, sort of think of like it's surfing on the superfluid.
Yeah, the temperatures hit like right at absolute zero, just barely under. That's what the German Soundly rocket showed us. It was like negative 471 Celsius when they hit like 70 miles. So that's possible. What gases go up? Helium, and that's right at the temperature and the negative pressure, or not negative. There's no such thing as negative pressure, but the low pressure that would make a superfluid. So that's possible. But and also the ISS looks like a little mini Arcturus, like a little TIE fighter.
Yeah,
I think it's natural, personally. I think, my opinion is natural, and that's why they twice were set to decommission it, but they didn't, and they keep backing it up. They're stuck with that fucking thing because they didn't put it there. God did. That's my opinion.
So I finally got the gift to. It's under 8 megs. So there you go. So that's the path of the ISS on
Who put
both
the
models.
astrolab up in? Who put the astrolab up there? Because that shit crashed down into Australia.
What?
There was
I think they
before the
tried to
ISS. There was another.
because it kept
There was
flooding.
another like ISS like thing. It was called the Astrolab, and it deorbited and crashed into Australia in like the 80s.
Yeah, and now and I think the ISS has to come down in like I think 8 years apart from now or something, and then they're gonna crash it down as well.
No, they have to clean the water that it's submerged in.
Yeah. Look, there's definitely something up there, but is it the
There's
people?
maintenance that you got to do on these.
Look, there's something up there, but is it people in that flying tin can in a vacuum? I highly doubt it.
Well, I'm pretty sure that all the footage is fake. There's no people up there, but I do think that because they're so confident in letting you trace its path and predicting it, like literally as dependable as a wandering star, that you, like you said, there is something up there. I just don't think that it is what they say it is. How they got it to look like a TIE fighter is what I'm still working on now. But if you think about it, look at the perfect path it takes. Completely ignoring the South Pole, completely ignoring the North Pole and the globe. What would be the reason? Like, look at that perfect, like, quote, orbit. It could just be in that, like, all things in, quote, orbit are actually in, like, the etheric drift and caught in the magnetic flux field and just have
Think
to
about
go
this,
from it.
though. That's a good possibility, but in my opinion, they're not going to have like they put that thing up with a high expectation of it being up there for like 20 years or something. Like, don't quote me on that, but for a little while, but it's way exceeded that. Mankind has not invented vacuum seals that can last that long.
Oh, thank you.
There would be
They
the
can
strength of the vacuum. There would be no bolt, no nut, no weld that could withstand that. It would rip apart. That would mean that your vehicle, your aircraft, is under constant pulling from every which way.
So I threw in the map of like the meme. Was it based off a meme of the satellite coverage when you guys were talking about that, not over the ocean? And then I asked Bacon to convert it to AE map, and he gave me 2 globes. The little cheeky bastard.
Oh, I give you.
And then the AE map. Yeah, I see that. Thank you, man. See, so that makes sense, right? So all the satellite coverage.
Auto globe at an antique store, and it said flat as fuck on it. So
Yeah,
I
but
bought it.
Yeah, but I mean, if you just go to a planetarium, you'll know that it's flat.
Why?
Because you literally use it on a flat surface and have a hemispheric dome to project the celestial objects on, exactly like you would observe it on Earth.
Right.
You know what I thought the Earth looked like one point? Like, you know how you have like the glass sphere that's on like a rock, and in the rock there's water coming out of it, so it kind of like spins the sphere, so it looks like there's water around it. You know, it's like a stress relief thing. You know, you've ever seen those? No.
Nope.
Let me get a picture then. Hold on.
Okay.
Yeah, object to the planetarium. The angles you get from I mean, the relationship you get from elevation and distance to ground position on a planetarium is not the one that works for navigation. You know that, right?
Sorry? Again?
The relationship you get between elevation angle and distance to ground positions on a planetarium
So it's a
does not
non.
match.
So it's a non-working replica.
Yeah.
That's
Yeah,
it.
you can say that the sky works as like a planetarium.
But you know
That
the
doesn't
planetarium.
actually
Yeah, but you
occur.
do know the planetarium is literally small scale. So obviously it's not going
Yeah,
to
but
work that way.
Yeah, but the scale doesn't change the angle. Like if you scale
Oh
up
yes,
where
it
you
does.
see
Scale
all
changes the
angles are
angle.
preserved.
Scale changes angles,
Sorry?
mate.
No, if you make a triangle twice as big, you don't change any of the angles. You only change the lengths of the sides. So a smaller scale of a triangle has the exact same angles.
But
So
we live in 3 dimensions. That triangle
Yeah, but think about this, man.
changes
This is
dimensions.
short scale. But check this out. So they have. So we find out that Polaris does a tiny circle. It's been there, in my opinion, for as long as mankind has. But whether that is or not, it does a small little tiny circle with a circumference of a couple hundred miles, like it's I think a third of a degree or something, or 2/3 of a degree. So you're doing all these measurements and all these corrections, like little tiny refraction corrections down to get it within 20 miles. But Polaris itself is freaking doing this circle, and it's measured as stationary. What's the point in all these little pinpoint corrections and all this shit if what you're measuring to is doing bigger circles than the damn corrections, man? I think you've been fooled, Bacon. That's my personal opinion.
What do you mean? Well, but if you assume that Polaris is on the center of the celestial pole, of course, how much it varies from the celestial pole, the celestial north, is a lot more than those corrections. But no one does that. No one assumes Polaris to be exactly there to get their coordinates in celestial navigation. They treat Polaris just like they treat all their stars.
You guys.
Planetoid, I just put a picture in general chat. Go check that out real quick.
General chat.
Yep.
Let's go check.
I don't know if Bacon Herbie or not. I don't know if Bacon Herbie, but if we're doing arc minute corrections and fractions of arc minute corrections, and Polaris is off by a third of a degree, it's off by like 1,000 arc seconds. I mean, what point in all these little tidbit corrections? And what's that have to do with the direction we're going? I think for navigation, I don't need to know how far. I can tell how far just by looking at a star. If I recognize it, just point me in the right direction. That would be the more important thing in my opinion.
Yeah, but you get the direction based on your location. So you first get your location, then you get the a direction. And Polaris, the difference between Polaris and the celestial north is accounted for. You don't assume that Polaris is exactly at the celestial north. Otherwise, you would be right. It wouldn't make any sense to correct for refraction, which is just a couple of like arc seconds or arc minutes.
Yeah, but the main method, the ABC method, has Polaris centered. So I don't know what you're talking about.
No, if you're doing celestial navigation and you cite Polaris, you don't assume that that's in the center of the celestial pole. If you go to the almanac, you're not gonna get 90 degrees of declination. You get 89
I'm
degrees.
aware of that. If you're measuring actual Polaris, yeah, I agree with you on that. But I'm talking about like the methods for the triangulation. But that's new information to me. I'll have to look into that. I'll concede that one for now.
All right.
But to me, so if I'm looking at a globe, I'm in Florida, and to get to Hawaii, I gotta head west northwest. So you're telling me if I could take a straight line from Florida to get to Hawaii, then I need to take a straight line from where I'm at west northwest. I find that hard to believe in reality. Or I'm pretty sure that I'm gonna have to go south at some
I
point.
didn't get that.
No, I'll drop it. I'll give somebody else.
All right. Right. Well, a flat side. Maybe that's not your position, but if I remember correctly, you claim to be able to do celestial navigation on flat Earth. Is that the case?
Sorry, repeat yourself quickly.
Right. Can you do celestial navigation on flat Earth?
It's always done on flat Earth. Elevation angles are based on horizontals.
Right. Can you get two coordinates, assuming Earth to be flat?
Your coordinates you get is always assumed flat. You only put in the hover sign afterwards because you have to duplicate the angle to make it a linear relationship. It's just the coordinate system, that's all.
Right. I'm not sure if you understood the question. I'm asking you if you can get the location of
Yes.
the observer given the readings of the stars. Can you?
Yes, I've even done it with the sun for McToon already. That's why he started straw manning me with for McToon. He's actually done it. He's actually tested me on it with the sun before, and I got the locations for two of the what's the names he's tested me on. That's why he started straw manning me about the two suns.
Well, I remember you explaining how to do a fix using the sun at high noon, which isn't what no one does because I mean, if you don't know your location, you don't have an accurate time for when it's noon at where you are.
If you on the ocean and you in the daytime, you're looking at the sun. That is what you're using to navigate, because you're trying to figure out your location. You're not going to. You're using it so you know your location. That's how it works.
Yeah, but, I mean, you're not going to use the sun alone.
Yeah, in the daytime you would use the sun. You're not going to see stars in the day.
You can see the moon, and usually they wait until
you can't always see the moon.
Twilight.
You can't always see. Yeah, but yeah, but like I say, you can do celestial navigation just with just the sun if you wanted to, or the moon. But yeah, it's usually used in the stars because then you're navigating at night.
It's a lot more accurate because you can get two bodies. A single body doesn't give you a lot of information to spot your.
It gives you enough information.
Of course, if you. Sorry?
It gives you enough information. I mean, just on logical deduction alone, let's take the sun for instance. You know it always rises in the east and sets in the west. So you're already going to know, okay, this is where the sun was rising, this is where I'm heading. So I would know if it's rising in the east, I know I'm heading south or north, so I'm heading more southeasterly or northeasterly. You understand?
Yeah, that tells you
that gives a lot of information. Yeah, but that gives a lot of information, and then when it gets to overhead at noon, you'll be able to say, okay, this is my time on my watch, because I mean you've already set it for Greenwich green time, and you have the sun, so you'll be able to say if you're plus or minus from that time, and that would be able to give you your longitude.
Okay. Can you do that before high noon and after the sun sets?
You use the whole day. You have to use the whole day though.
Well, I'm interested in how you'd solve for like a 2-star fix. Right?
Okay, but we're talking about the sun. Okay, let's just move on to night then with the stars then. That's easy.
Sorry?
Okay, then we just move on to night then with the stars. We're not doing the sun then. That's fine. Just like you would do normal celestial navigation.
Yeah.
You're using your sextant. You're taking your angular measurement, which is done with an elevation angle. The elevation angle is taken to the same equatorial plane from the GP of the star. That's how you're getting your measurement fixes. The only thing you guys like to straw man is, because you use the nautical almanac to know the GP positions of those stars that you measured, you say therefore globe. No, those GP calculations are done from thousands of observations through thousands of years. They know what time a star is at its local GP. It's just the coordinate system.
I'm aware of that. I'm not claiming any of that. I know that the almanac tells you what's the ground position of the stars at each or any other celestial body at any moment in time.
Yeah.
But I'm asking you the process, like how you derived your location from 2 star sites, for example. What exactly do you do?
You set up your sextant and you take your angular measurement. You're bringing it down.
Yeah, I get that part.
There, which is an angle measurement, which means it's flat. You're asking how we're doing it on a flat. It's the same as you just do it on the globe. The only difference is we do not duplicate the layer, the angle measurements, to a center of a sphere. That's all we do. We do not duplicate it because you literally take. You saw my diagram where I took the angular measurement, and you take the co-altitude angle and you just times it by 60 to get your nautical miles. So you know your distance from that star.
Why would you do that?
So you get your distance from that star. And because you know you're looking at the fix
If
to
you-
that star, you know the GP of the star.
Right? Do you think that distance is accurate?
Yes, those distances are accurate.
Yeah, they don't match a plane.
They match a plane perfectly.
Okay, if you have a four-sided polygon with two diagonals that match, they have to be the square root of two of the sides, don't they? If they're on a plane.
Everything you're looking through, you know that sextant, it's an angular measurement tool. Correct. What? An angle.
Yeah, I'm not asking about the readings.
That's
So you're
exactly what
assuming
it
that
is.
you're assuming that it's a flat Earth and the stars are a flat plane above it. Is that what you're
Exactly.
assuming and asking if it would work? And you're assuming no refraction or nothing's going on, just you're trying to. I mean, is that what you're asking? I'm just trying to clarify.
Me?
Yeah.
No, I'm asking how he derived the location based on the readings. He just told me how he does the readings.
I already
not
told you,
telling
it's
me
68 miles per degree. So if we have a partial atmospheric dome, and or there's other explanations, but just a quick one. If we have a partial atmospheric dome that the stars are shining on, and they project and they interpret out to 69 miles per degree, what's the problem?
I'm not saying there's a problem. I'm asking how he derived the location.
I just told you.
So, no, no. I mean, let's go into more detail so I can try to do an example out of your explanation. Like, if you're just explaining me in such a way that I can't put my hands like to work and do that, an example out of that, then you didn't explain me well enough. You just gave me rough ideas that you have in your head. You're not giving me anything that I can actually do. And what I would like from you is something that I can actually do.
Bacon actually did. He said that you measure the elevation angle, and whatever degrees is, you multiply that times 69. So what do you mean he didn't tell you what to do? What we do in reality, right?
That gives me a distance to the ground position.
Yeah, and then you pick up your
What
ground.
would
And your ground position is based in your almanac, so you know where it is on that time. So you've already triangulated your one fix. Then you do it to the next
Okay.
star, and therefore you got your LOP, line of position. I don't see what the issue is.
Oh, how do you get to a line of position?
By doing more than one fix.
No, I mean, the reading. I mean, you're talking about a reading, not a fix. If you're citing a star, that's not a fix. That's a reading.
That
Each
it-
reading is going to
He's
give you a line of
talking
position.
about for each individual star flat. So
Yeah, those
Okay.
aren't fixes. Those are readings.
Okay,
I'm just,
readings, yeah.
But like I said, man, I'm gonna humble myself and go with what I know, and you use 69 miles per degree. If you want to claim that that's happening because the ground's curving, my argument would be that there's another reason that's happening. And I just gave you a possibility, and other people have several others that are pretty
it's
fair.
actually it's
Yeah.
actually very simple.
I'm not even asking.
It's actually pretty simple. We do exactly the same way you guys take measurements. The only difference is we do not duplicate the angle measurement to put it to a center of a sphere. We literally just keep it as it is on the spherical dome because of field of view. That's it. Where we see it
Can
as
you do an
where we
example so I
where
can
we see
understand
the
exactly what
co-altitude
you're
angle.
explaining?
Where we see the co-altitude angle as a perspective-based angular measurement, you guys see it as a physically lowered angle. But the problem is you guys can't get that angle if it was a curved surface. That's why you had to duplicate it to the center of Earth, hence why you have an equatorial plane.
All you need to get the angle is to be able to sight the horizon, sight celestial body, and know how much the horizon is below horizontal. That's all it's required. Doesn't make any sense to say you can do that on a sphere. But that's not even what I'm asking you. I'm not asking you how you take the readings.
I do it exactly
I'm
the
asking
same
you-
way you would expect to do it on a sphere. You climb on your boat, you use your sextant, you take your readings, you look in the almanac, where's the GP, you do the next one until you get your fix and your on a position. It's as simple as that. I don't see what the issue
That's
is.
a hell of a jump.
Why?
Because
It's
when I
exactly
get
the
GP
same.
One second, dude. It's very easy to get the GP. It's very easy to get the reading. We all agree so far. That's the point in which everyone does the same thing. Everyone does the same thing regarding the reading and regarding the ground position. That's okay. That's easy. That's fine. Now, once we have that, once we have the readings and the ground positions and the distance if you're using co-altitude times nautical miles, how we then get the location. What exactly you do to end up with the location in your hands.
I don't understand what you're saying.
Right, I have reading.
You already have it, so I don't understand.
If he did, I could make an example out of what he said. I have no idea how to make an example of what he said, so there's a lot of information missing.
What information is missing?
Take a Mercator map, or any other map, measure the angle, get 69 miles per degree to that elevation angle. I think that's the first thing he said, right?
Yeah, you're literally taking you're taking the data that you got on the time, so you can get the longitude. There's already giving your one coordinate system, and then you're taking the data that you got to the angles and the distances to give your other coordinate system. It's just a coordinate system based data reading. That's all it is.
Yeah, I'm not asking for justification. I'm asking for details on the process, so I can do that again. Brian, you said I can get the Mercator or any map. Each map is going to put me in a different location if I'm using the same distance.
Not if you're using coordinate systems.
As far as taking the measurement and then subtracting the UTC, the Greenwich Mean Time, from you talk about going to Almanac. You want all the specifics? Is that what you're asking for, or are you asking for like model wise? Because all the Almanac gives us is is pretty much the declination angle to freaking Aries, basically.
Yeah.
It just tells you where it's at in accordance to the circle and its point around Aries, right? And then
it's just a coordinate
system.
system.
Flares, and then you can got to work out based on your time. You got to work out
that's the part in which we all agree. That's the part in which we all agree.
Yeah, it's just a coordinate system.
I'm having trouble understanding what you're asking for, bro.
Right, I'm asking for, given let's say I'm on the ocean, I take readings from celestial bodies. I take the elevation angle of each celestial body. I apply dip correction, I apply refraction correction. I remove the index error. I do all that I have to do, and then I go to the almanac.
Wait. No, you needed an almanac first. Wait, you're saying you took an angle, so all you have is you and an angle, and you're sitting in a boat.
I don't need the almanac first.
Now what do you do? Yeah,
use the almanac. The almanac gives you. The almanac it gives you your. The almanac gives you your corrections.
The almanac before readings.
The almanac gives you corrections.
Corrected. You do need to right after the reading. Sorry, I stand corrected.
Yeah, right off the reading.
Okay. Yeah. Exactly. You don't need the almanac to take the readings.
No, obviously.
The corrections that you use the almanac is like you can actually derive dip and refraction correction from the.
But if all you have is a boat and an angle, you're fucking shit out of luck, right? If you're just out in the
I didn't say I don't have the almanac.
and all you have is an angle, that you got nothing, right?
Yeah, obviously.
Yeah, but that's not what I'm describing. I'm describing a situation in which I take two readings. So I point to, let's say, Procyon, and I point to Acrux. So I take two readings, one from Acrux and the other from Procyon. Yeah. Now, I go to the
northern hemisphere stars, bro. We don't like the southern hemisphere stars, man. I'm just joking.
Sorry, guys.
I said the ones that I use the most because I see them the most. But
yeah, but sorry, guys.
Okay, let's use then Capella and Reggio.
But they named the other cruxes because it's probably wrong down there, and they're like, "Look, that's the measurement if you go off of A crux." And they're like, "No, did I say that? No, that's B crux, man. That's or tricrux or whatever, man. That's the wrong crux, man." Like, I'm just joking. Go ahead. I'm sorry to interrupt.
So I just have to say, guys, the power's going off in like 12 minutes. So we've got like 10 minutes left. You guys can obviously still go on afterwards, but the stream's just going to end in about 10 minutes, okay?
Sure.
Shots. But I think we should actually do another thing with actually in celestial navigation then, if you want to go into more detail on it. It's just not we're going to have time to do it now.
In all fairness, I did interrupt him. Can we let him finish his point?
Yeah.
Well, the situation I was describing is I'm in the ocean, I take two readings, I go to the almanac, I apply the corrections, I find the GPs of those two stars based on when I took the readings. So now I have two ground positions and two angles, corrected elevation angles. The next step is to turn those elevation angles into zenith angles by just subtracting that from 90. So now I have two zenith angles and two ground positions. How that's so far so good. We all agree on
that. Like I said, then you go to the almanac, okay, and you get the freaking the differential basically off of or the measurement from that it is from Aries to get your line of position.
I don't need that.
Okay, you gotta subtract the time. You gotta look at the time, get the exact time, and then look at the almanac. It's gonna give you the position of the star. You gotta identify the
I already did that.
star. Okay, so you're saying after that.
Yeah. After that, how do I then arrive at my position?
Bob's your uncle. Bob's your uncle after that.
Yeah, so let's say I give those information to Flatsoid. So Flatsoid, those are my readings. Those are the ground positions of the stars at the moment when I read them. Where am I? So
Sorry?
I would be interested in what Flatsoid would do with that information.
Sorry, say something. I'm
And you
watching.
make a line. You make 3 lines.
I'm watching a guy play with a globe ball on the.
Anyway, you take 3 lines on your map, and wherever they cross, like there's usually a little triangle they call a devil's hat, and somewhere in the middle of that triangle is your location, right, on the map.
Excuse me, say that again?
You draw your 3 lines out. I mean, you usually do too to simplify it, because we know it's not, obviously, it's easy to tell one from the other just using 2 once you've done it a little bit, so you're good at it. So let me give a shout out to Bacon. He is the one who won the $100 reward or award from Tune for the first one to call in with the location. I'll give him a shout out for that. And but yeah, you line it out and just say we take the 3, we make 3 lines, and where they cross, you draw the 3 lines on your map. Where they cross, unless they're perfect, you have a little triangle, which is called a devil's hat, and you're
I'm aware.
You're somewhere within that triangle.
The corporate head. Yeah, I'm aware of how it's done, but the problem is if we're using a flat Earth assumption, how do we get those lines of position? Because the way I get those lines of positions is by using the azimuths that you'd get on the sphere, and then the distance between those. Yes, that's what people do in celestial navigation.
Like you take the flat elevation angles, and you do everything flat, and then you project it on a flat map, and then just say, well, that's on a sphere. Let me get this right.
They're just angles, they're not flat angles, they're just angles. And they tell you distances. So now you have a distance that you measured, and you have to correct for that. So the way we got
to bring a globe out there if we're navigating. We need to bring a globe with us, right?
Or side reduction tables, which does the same thing as a globe would. It's exactly
You mean
what
the reduction tables that are built in?
The reduction tables that do what a globe would do. I mean, if you want to do if you want to pick a globe and do that physically, like with a physical globe, you're gonna get the exact same thing you get from the side reduction tables. Side reduction tables is just a way you can do that using pen and paper, and instead of using like a physical globe. It's not something different.
Well, have you checked out the Swiss ephemeris yet? I mean, have you even looked at that? They have the Swiss have the ephemeris where it's mapped out on an AE map or a globe. There's some transforms. It's basically not a transform. It's like pre-transform. So in other words, when you do the site reductions and you're going to use the Haber sign, that's got a built-in radius. Okay. So as far as making it work, yeah, you found a way to make it work within a good margin of error. But as far as using that to prove the Earth's a globe, that's ridiculous in my opinion. You're just kind of like using the model to prove the model.
That wasn't even my point. My point is the way you get the line of position is using 2 things. You have the calculated distance. Sorry, 3 things. You have the measured distance, the calculated distance, and the azimuth. Both the calculated distance and the azimuth are derived from globe math. The only thing that's not derived from globe math is the thing you're measuring. So you're comparing the thing you're measuring to something you're deriving from a globe to fix your position. I don't think that's what Flatsoid's doing, because he said he does that on flat. So I don't expect him to use math that is being used as an analog for a globe. So that's what I'm interested in how he would do. I'm not even saying this proves a globe or anything. I'm just interested in how he does it, because he says he can do that. And he can do that by assuming Earth to be flat. So he wouldn't use those same lines of position.
So the maps we trim onto are 2D, is a two-dimensional grid, right?
Yeah, but I mean, take for example the size of the longitudes. They are adjusted based on your latitude, and they get
a Cartesian system doesn't make it a globe.
We're position and put them on a 2D grid, right?
Yeah, they're a local representation of where you are.
It's just a coordinate system. It doesn't mean you can take that same coordinate system and wrap it around a donut if you wanted to.
Well, not really. Not given how you adjust for the sizes. Now, how you adjust for the sizes of the longitudes. So, for example,
it's just a coordinate system. The drawing of that map on the different continent scales doesn't make it that true size. It's just coordinates. That's the thing. If I take a coordinate system from your globe, I can put the same coordinate system on a flat map and I'll get exactly the same coordinate.
Well, but for example, this geographical north wouldn't be a single point on a donut. So you wouldn't get the same azimuths, you wouldn't get the same, it wouldn't be analogous to a donut.
Why?
Like say if I measure it out and I get a distance of like, let's talk about pre-computer, which has been most of man's history.
Sorry, Brian.
I want to confirm that distance over the ocean.
Sorry, Brian. Sorry, before you guys go on, I just got to say the power's going to go off now. So I'm going to have to leave there. You guys can carry on. Really appreciate you guys coming tonight. Yeah, it was an awesome thing. I think we can do this more than once. If you guys want to do this more regularly, because I enjoy this. Yeah, that's awesome. So you guys can carry on with the talks. I'm unfortunately I have to go. The power's about to go off. So
I'd like to, it's been a pleasure, Platt. So we appreciate it.
Shot.
Right, so see you tomorrow night then, yeah?
Yeah. Cheers, guys. Bye.
Same here.
Bye. And then all you guys in the chat, thank you all for coming. Appreciate you all being here. Thank you all for showing up. Thank you for all the super chats and everything. It's actually very simple. Celestial navigation is done flat. They use the hover sign afterwards because they duplicate the angle to the equatorial plane, the center of the globe, because they need it so they can have a linear relationship. It's just, that's also them ignoring that perspective. That's about it. But my power's about to go off, so thank you very much all for coming. Sorry I'm not showing my face today. Yeah, I look like a cross between Frankenstein and and The Simpsons. So thank you all for coming. It's really been awesome to see you guys. We'll see you guys tomorrow night. Till next time, God bless. May the pressure be with you.